Welcome back to The Explainer. Today, we're essentially cracking open a digital time capsule to explore Java applets. This is literally the foundational tech that brought the early web to life. If you've ever wondered how those static HTML pages from the 90s and early 2000s first started, playing interactive games or running complex animations right before your eyes, well, you're in exactly the right place.
We completely take modern interactive web apps for granted today. But before all this sleek infrastructure existed, developers faced a massive hurdle. They needed a safe, reliable way to execute complex logic directly inside a user's browser, and they had to do it without accidentally compromising the user's entire computer. So, how did they actually pull that off?
Here's our quick roadmap for this explainer. First, we'll meet the Java applet, compare apps versus applets, map out the applet lifecycle, explore its underlying architecture, and finally, look at how to compile and run one.
Starting off with Section 1, meet the Java applet. Let's get a baseline definition of what an applet actually is. Now, obviously, these are deprecated in modern computing, but back in the day, a Java applet was basically a specialized mini program. The real game changer here was that it was designed to live directly inside an HTML page and run automatically by the browser. There was no double-clicking an icon on your desktop, you just navigated to a web page and boom, the code sprang to life. Looking at this diagram of the standard Java platform, you can see exactly where they fit in. It didn't really matter if you were running a massive enterprise server app or a tiny little web applet, it all relied on this exact same Java virtual machine and API structure. The JVM was the ultimate bridge, seamlessly translating your compiled code into instructions that your specific hardware could actually understand.
Moving right along to Section 2, Applications versus Applets.
To really grasp how unique applets were, we've got to compare them to what developers were already used to building. The core tension between a standalone Java application and a Java applet really comes down to trust and execution. Applications are trusted. You, the user, manually invoke them via the JVM. Applets, though, they're inherently untrusted, and the browser invokes them automatically, just because you stumbled onto a web page. Let's use a quick metaphor here. Think of a standard Java application as a homeowner. The homeowner has full, trusted access to the entire house. They can read files, write to the hard drive, use the network ports, whatever. An applet, on the other hand, is basically a guest worker. Because it's downloaded automatically from the Wild West of the internet, it is strictly untrusted. It's confined to a sandbox with very limited system access. This sandboxing concept was absolutely revolutionary for preventing malicious code from wreaking havoc on your machine. Breaking down the technical specifics here, the structural differences are super clear. For execution, apps are run manually via the JVM, usually with the Java command, while applets just run automatically in the browser. For the entry point, applications absolutely need a public static void main method to start. Applets don't have a main method at all, they just extend the applet class. Security goes from fully trusted to strictly sandboxed. And even the default layouts change. Apps default to a border layout, but applets use a flow layout, which just makes total sense for fitting into the natural flow of a web page. But wait, that actually brings up a really fascinating question. The main method is the heartbeat of almost every traditional program, right? So if an applet doesn't have one, how on earth does the browser know when and how to start it? Which brings us perfectly to Section 3, the Apple lifecycle. The answer is that applets are completely event-driven. Instead of the program dictating its own flow, the browser container is firmly in the driver's seat. As you can see here, the browser calls specific methods at specific times based entirely on what the user is doing, starting right from the moment the applet is loaded onto the machine. The whole lifecycle follows these 5 exact phases. First, a init runs just once when loaded to set up your variables and GUI components. Then, start kicks in when the web page actually becomes visible or active to the user. Third, paint is called to draw the visuals on the screen. Fourth, stop is triggered if you leave the page, which lets you pause heavy tasks like animations. And finally, destroy runs exactly once when the browser closes, sweeping up and clearing the whole thing from memory. I want to zoom in on that third step for a second, because paint is where the visual magic happens. After init and start, the container calls paint and hands it a graphics object, basically your digital canvas. It uses a super precise pixel coordinate system where 00 is locked right in the top left corner of the applet window. Every single line, shape, or button the user interacts with is drawn relative to that top left anchor.
All right, Section 4, Architecture and Hierarchy.
To actually pull off these robust graphical features, an applet inherits traits from the standard Java Abstract Window Toolkit, or AWT.
Check out this family tree. It starts at the absolute base with object. Then it inherits from component, letting it display on screen and interact with users. Next, it becomes a container so it can hold things like buttons or text fields. Then it narrows to a panel for organization. And finally, at the very end of the chain, it becomes our specialized applet. It is literally standing on the shoulders of giants.
And finally, Section 5, compile, embed, and run.
We've got the theory down, so let's look at the practical workflow. Getting an applet on screen is a three-step dance. First, you compile your human-readable source code into machine-readable bytecode using Java-SE in the terminal. Second, you embed that resulting class file straight into an HTML document. And third, you run it.
That second step was completely unique for its time. This specific HTML applet tag is the magic link. It explicitly tells the web browser exactly which compiled class file to load, like helloworldapplet.class. But more importantly, it acts as a real estate manager, telling the browser to carve out a very specific box on the web page, say 300 by 300 pixels, dedicated entirely to this sandbox Java program.
Now, because this is very much a legacy system, developers who are testing this code today or doing so outside of a fully configured browser back in the day use a JDK utility called Applet Viewer. You just type Applet Viewer and your HTML file name into the terminal, and it parses the HTML, finds that applet tag, and runs the program in a dedicated testing window. It perfectly mimics the browser's lifecycle environment. So, as we wrap up this explainer, we really have to give credit where credit is due. Yes, Java applets are a deprecated legacy concept today, but their DNA, it's everywhere. Their strict, sandboxed architecture literally defined modern web interactivity. They proved we could safely run complex, dynamic code on a stranger's machine without causing total disaster. Which leaves us with a pretty compelling question. As our web applications become even more decentralized, complex, and deeply integrated into our lives, what massive computing system will we need to sandbox next? Thanks for exploring this digital time capsule with me.